Welcome back to my channel. In this video we're going to be talking about classical free electron theory. Before going to this topic, we're going to be discussing a brief history related to the atoms. In the earlier days of 400 BC, there was a philosopher called as Democritus. Democritus said that anything which occupies space, we call it as a matter, and this matter is made up of a tiniest particle, and this tiniest particle is given a Greek name called as atomus. And by inspiration of this particular atomus, in the 18th century, a school teacher, John Dalton, given the spherical model where he considered atoms are in a spherical shape. By the inspiration as evolution, the J.J. Thomson invented the electron. Rutherford eventually said that there is a strongest opposition in the center of an atom. He called as a nucleus, and he invented the proton. And there was a huge confusion why this particular metal and the non-metal has a different magnetic property and electrical property and the thermal property, especially in the solids. And at the end of this particular 19th century, they had a clear picture exactly that center of this particular atom is always called as a nucleus, and surrounding that there was a plenty of electrons, which we call it as a free electrons, and that will be most responsible for this all properties. And they were not able to explain by any theory how come this magnetic property, thermal property, and especially electrical property is varying from one metal to another metal, especially like in a solids, metal and a non-metal. There was two scientists in the 19th century, Drod and Lorentz. They came up with the idea related to an electron. They said that the electrons which are freely moving around this atom are exactly similar to the gas molecules, and they compared these electrons as a gas molecules. And they have given us 7 assumptions related to this, and this assumption was always obeying a classical physics, and they have given this title for this assumption as classical free electron theory. Whether this worked, were they able to explain this physical property, and whether it was so effective, and anything there was a fault related to this assumption, we are going to be discussing in further. Assumption 1. In metals, there are a large number of free electrons moving freely in all possible directions. So in a metal, there will be a plenty of atoms where individual atoms will be having a free electrons, and it will be moving in a freely in a random directions. Assumption 2. The free electrons behaves like a gas molecules in a container, obeys the laws of a kinetic theory of gas. Means this free electron exactly it will be behaving like a gas which is completely filled in a container in a random directions. Assumption 3. In the absence of a field, the energy associated with each electron at a temperature T is given by 3 by 2 kg. Means the kinetic energy possessed by an electron is exactly compared with the kinetic energy of a gas molecules which is confined in a container. Assumption 4. In metals, the positive ion cores are at fixed position and the free electrons moves randomly, and collision either with positive ion cores or with other free electrons or with boundaries will be considered as like elastic collision between the molecules. Assumption 5. The average amount of energy involved in each different direction of a motion of an atom is the same. Means the total energy possessed by electrons which is moving in a random direction on summation of this particular total energy will be considered as equal to 0. Assumption 6. The free electrons moves in a constant potential energy, hence the potential energy of an electron is considered as a constant. Assumption 7. When an electric field is applied to a metal, Free electrons are accelerated in direction opposite to the direction of applied field with a velocity called as drift velocity. Means applied field, if it is in a clockwise direction, the flow of electrons will be exactly anti-clockwise direction. So this was the 7 assumptions which was made by the classical free electron theory to explain the conductivity of electrons in a metal.